Hi everyone, and thanks for joining us for another particular live webinar. This is Daniel Marbach speaking, based in Switzerland. Today I'm here with Mauro Servienti, based in Italy, to talk about asynchronous messaging with NServiceBus. In the last webinar, Elton showed us the VTRU pattern, which is consistent of the validate, enrich, transform, route, and operate steps. I'm going to talk more about that as a brief recap, and also how a message-based architecture can allow you to scale your applications. A quick recap on the VTRU pattern. It's an enterprise integration pattern consisting out of validate, enrich, transform, route, and operate. And all these 5 steps, they can be actually processed in parallel, so they don't have to be processed in a sequence. We are going to focus again on the sample which Elton provided us, and this sample only showed the steps validate and enrich, so please keep that in mind. Then Elton also talked about the message queuing architecture behind his samples. The message queuing architecture was based on a single host which was sending messages to a message queue, and multiple hosts like a validation host and, for example, 2 enrichment hosts were feeding off these queues and processed the messages. This architecture allowed us to almost infinitely scale by adding multiple consumers to the same queue. Mauro is going to present you in the demo shortly coming, the demo application Elton showed us in the last time, but this time based on NServiceBus. So Mauro, I'm handing now over to you.
So thanks Daniel, and welcome everybody. Can you also see my screen? Okay, so as Daniel said, last time with Elton we saw this sample application that was based on basically 2 endpoints, where the 2 endpoints were the two different console applications running 4 different logical endpoints. One of the endpoints was called by Elton the producer, where the producer was the endpoint responsible of delivering requests to the consumers in order to process incoming messages. The architecture was fairly easy. It was based on a banking and financial scenario where messages in an XML format were flowing in from a third-party source. The producer was responsible to watch a folder, looking for these XML files, and each time a new XML file is received, the producer will pick up that file, will elaborate it a bit, and produce a message on a queue that will be consumed by the consumer's endpoint using the VTRU pattern. So basically the consumer's endpoint were exactly the same code base, run 3 different times, attached to 3 different queues, where each queue was responsible for one of the steps of the VTRU pattern. In the Elton samples, the first step was the validation step, and the other 2 were 2 different enrichment steps. What we did is to basically modify as less as we could the Elton's code sample in order to introduce NServiceBus, removing all the code that Elton's was forced to write in order to supply all the infrastructure required to deal with the bare MSMQ thing that he was using. As you can see on my monitor, on the left side there is the original Elton sample, and on the right side there is the new Elton sample based on NServiceBus. The project is exactly the same. There is no name changes, nothing, exactly the same. We are looking right now at the consumer endpoint, and the producer endpoint has received the same type of changes. If we look at the left side, what you can see is that the first thing that Elton is doing is creating an instance of the Unity container that is required by the Elton design to being able to supply dependencies to message handlers. And then Elton registers the trade context factory, where the trade context factory is the thing capable of providing the data context used by entity framework to access the underlying storage. And then Elton is registering 3 different message handlers. Each message handler is responsible to handle one type of message in Elton's scenario and in ours as well. We haven't changed anything related to messages. The last thing that Elton is doing is registering a message handler factory. A message handler factory in Elton samples is required because from the message queue point of view, there is no correlation at all between a raw message that is just a byte array of things incoming to a queue and a piece of code that should handle that type of message. So what Elton is doing in the message handler factory is basically picking up a message from the queue, trying to deserialize this message, assuming that the format is the expected one, and then based on the content of the message is invoking one message handler or the other. The last thing that Elton is doing is starting up a new queue, passing in as an argument the input queue that is passed to the endpoint on the command line, and then starting this while cycle, never-ending cycle, that will pick up incoming messages from the queue. Each time there is a message, this message will be passed to the handle method, where what the handle method does is try to understand how to handle the incoming message. So basically, Elton is asking to the handler factory, please give me all the handlers you know for this message type, and then deserialize the message and invoke the handlers in a for each loop. So basically, what Elton is trying to achieve is to be able to handle multiple times the same message in the same transaction with the queue within the same endpoints. On the right side, we can see basically the same thing done by NServiceBus. The first thing we do is to create, exactly as Elton is doing, a Unity container. NServiceBus supports multiple container type. So by default, we run on Autofuck, but we support Castle Windsor, Unity, Spring, and several others. And we are supplying this Unity container in order to be able to register types in the container itself that are not known by NServiceBus up front. In this case, the only type we need is the trade context factory. From the NServiceBus point of view, only the connection to the database where user data are stored is an unknown thing. All the other things are already known up front. The second thing we are doing is creating a bus configuration. The bus configuration is the entry point to create a bus instance. The bus configuration is used to configure all the details required by the bus in order to run correctly. And these details, there are a couple of things that are mandatory in order to create a new bus instance. One of these things is the endpoint name. The endpoint name by default is deducted by NServiceBus using several conventions. Let's say that the default behavior is to use the application default namespace. So if we do not specify anything in this endpoint name method, the default name of this endpoint will be the namespace of this class. So 6-sided, going async, fv2 consumer. In this case, we are specifying the endpoint name using something from the command line in order to be able to run the same project multiple times, behaving as different endpoints attached to different queues. In this case, we are running it 3 times. The second thing we are doing is one of the most important things from the architectural point of view that NServiceBus can enforce in your project, that is defining the message conventions. One important thing when you are going to build a distributed architecture is to strictly define what messages are, what commands are, and what events are. In this case, we are interested only in messages, so the simplest thing that can be moved from one endpoint to the other. And we are saying every class, every type that matches this convention, so where the namespace is not null and the namespace ends with messages, with dot messages, will be treated as a message by NServiceBus. What does it mean? It means that only types matching this convention can be delivered from one endpoint to the other. Meaning that if we try to use as a message something else, NServiceBus will throw, preventing us from doing things that from the architectural point of view are not really the right thing to do. The third thing we are doing is configuring the endpoint persistence. In this case, we are using the default in-memory persistence that is highly not suggesting for production scenarios, but since we are not doing anything related to NServiceBus persistence in this sample, we can live happy with the in-memory persistence thing. The last thing before creating the bus is asking to NServiceBus, please do not use your internal version of control container, but since we already have one where we have registered something, please use that one and register your own types into the user-provided container in order to be able, within the handlers, for example, to mix dependencies using both dependencies from the NServiceBus assemblies and dependencies from the user-provided assemblies, so dependencies related to the user business code. The last thing is to finally create the bus. Giving a configuration, we can call this static method on the bus class, asking the bus to create a new bus instance, and finally we start it. Starting the bus equals to what happens on the left side of the Elton cone, that we start polling the queue. Basically on MSMQ there is no push model, so what MSMQ does is receive a message and live happy with that message in the queue, and so we need to start polling the queue in order to understand if there is a new message. But all these things are handled under the hood by NServiceBus. And as you can see in the right side configuration, there is no reference at all to MSMQ in any way. MSMQ is the default transport used by NServiceBus and is basically equals to specify configuration.use transport using the generic type MSMQ transport. So one of the advantages in this scenario of NServiceBus is that we can switch the transport transparently to the application, because you can also configure that transport type into the application configuration file, for example, and without including into your code anything that is related to the transport details, as in this case. The other thing I'd like to compare is how handlers are defined. In the Elton's code, we have this enrich party handler that is one of the handlers that inherits from the the iMessage handler interface. The iMessage interface is defined by Elton and is used by the Elton's code to detect that the class is a message when registered into the Unity container. Given that this class will be registered in the Unity container, it can have this class specifically can have dependencies registered as well in Unity. So in the constructor, Elton is asking for the iTrade context factory to connect to Entity Framework and then to SQL Server, and to a couple of booleans in order to understand if this handler is an handler for the enrich party 1 or enrich party 2. Enrich party 1 and 2 are two different steps of the enrichment process. And this is just one of the things that smells in the Elton's way of doing things directly with MSMQ. Since we do not have inside the MSMQ message anything capable of deciding what type of message it really is, we are required to introduce this boolean in order to understand how to handle a specific message. Then any message handler is required to have this is handled based on a string that represents the message type, where the message type is a string that the producer of the message will insert in the message delivered through MSMQ. So a message handler is capable of saying, I can handle this message type, and that's it. once the Elton's code is capable to understand that a message type can be handled by a specific handler, that message type will be casted to a iMessage interface, where iMessage is still required by the Elton's code in order to have some sort of a common contract between messages, being able to say, well, a iMessage will have a trade ID or a message ID or whatever is required by the architecture that we are designing. And then we are doing this funky thing using the Boolean that we passed into the message handler constructor, saying if this message handler should behave as the enrichment handler of the party 1 or the party 2, then do this or do that, based on the decision made outside of the handler. On the right side, we have this exact same code done using NServiceBus. So we have introduced the iHandle messages interface instead of the basic iMessage handler, where the iHandle messages interface is a generic interface closed around the message type. So we are basically telling to the infrastructure, if the deserialized message, so the incoming message, is of this specific type, then I am the right handler of this message. The interesting thing is that from the iHandle messages point of view, we can support inheritance. So what we can do is basically write something iHandle messages of object and be a catch-all in that specific endpoint. That message handler will receive every single message delivered to that endpoint. And we can use whatever inheritance chain we'd like in our code to achieve this multiple management of messages within handlers. Then, since we have a strict dependency of the message type at the handler level, we were able to remove the two booleans used to detect the message type, and we also removed the isHandled method in order to say this handler is capable of handling this specific message type. So we have just the dependency of on the trade context factory required to connect to the database. Then the handle message, once again, the handle method, sorry, once again, is strictly closed on the message type, and what we just do is open the database connection and do whatever we need to handle the message. The only difference you can see between the two code is that I added this guard in order to be able to run the sample multiple times without worrying about the fact that we were destroying and recreating queues at setup time. So it is just required because we want to be able to run the code multiple times, and that's it. The code is unbelievably simpler. From the message point of view, one interesting thing is that if we have a look at the message class, the main difference is that our message class, so the message class required by NServiceBus, has no dependency at all on anything. It's just a plain old CLR object, where the only real requirement is that based on the serializer type you are using, this class needs to be serializable, meaning that if you're using the XML serializer, properties must be public and both getter and setters must be public. If you're using the JSON serializer, you can configure the JSON serializer to easily being able to hydrate private properties and private setters without any particular issues, but it's just a technical detail in this case. NServiceBus is capable to understand that this class should be treated as a message because it matches the convention we have introduced at configuration time. So we have this way to separate things from the architectural point of view, saying at configuration time, please treat this set of classes as messages, commands or events, depending on what we are trying to do with the bus. So I'd say that the main difference that we have, we can see the same thing basically from the producer point of view. The producer point of view that Elton created was much more complex than the one we have. In order to send a message, we are only required to start the bus, and nothing else. And once the Elton watcher find that there is a new message to be processed, what the new Elton's watcher does is to process existing files and then process the new incoming files that require this process will be just the bus.send in order to send a new message. Let me look for the implementation of this so I can just, oops. So at the process time, what we have is just the incoming file watcher asking to the processor to please deliver this for me. And what the processor does is just send the new message. So from the processor and producer point of view, the delivery of a message is just a matter of asking the bus to send something. The main difference from this code compared to the Elton's one is that in the Elton one there is a relation between the message and its destination. So Elton's was, because MSMQ has no knowledge at all of any routing strategy, Elton's was required to being able to send the message somewhere and encode that somewhere into the sending process itself. From the NServiceBus point of view, what we are capable to do is to, at the producer, that is the only interested in knowing where to send the message, add this destination based on a configuration. So we have this unicast bus config section that says, given this assembly, 6i going async.core, and given this specific type, that is one of the messages, so within this assembly, just pick up this type, this specific type should be delivered to this endpoint, where in the case of MSMQ, the endpoint name is the MSMQ address. On a single machine, this implies at localhost at the end of the address. So we are just configuring where each single message type or a set of messages, because at this level we can use only the assembly attribute, meaning that all the messages in this attribute will be delivered to this endpoint, or we can specify a single type, or we can specify a namespace to narrow down the scope of the messages that should be delivered to a specific endpoint. But one of the interesting things was that we were capable to extract from the code the routing strategy in order to separate the routing topology from the code itself, that is not required to know where a message should be delivered. These are the mostly significant changes that we have done to the Elton sample, and the biggest difference and the most important difference that you can see as soon as you look at the code is that the number of lines of code required to achieve the same goal are far less using NServiceBus compared to the Elton's sample. It's obvious that one of the goals that we do not want to reach is only to reduce the line of code that we need to write, and I suppose that Daniel is interested in saying something in this case.
Yeah, Mauro, I think it's important to mention that it's not only about the reduction of the code size that we should be using NServiceBus in that sample. I think we all know that our attendees following this webinar are rock-solid programmers and can potentially write dozens of lines of code in a matter of minutes. I think it's more about building on the shoulder of giants. So the queuing code NServiceBus provides has been battle tested by hundreds of customers and of course installations around the globe. So NServiceBus itself is not only an abstraction on top of your queuing system, but also provides a number of features which you shouldn't be building yourself. So for example, let's discuss what happens in Elton's code when our business logic raises an exception. I did a stupid mistake here. For example, in the party enricher, which Mauro previously showed, I'm throwing an argument exception just to simulate exception cases. So in Elton's code sample, what would happen is the message would be processed successfully out of the queue, but the code would actually throw an exception and the entity framework database transaction would be rolled back. And I think that's a pretty terrible case, because from a messaging perspective, the message is gone, but our business logic hasn't been executed successfully. NServiceBus itself has the concept of the so-called first level and second level retries. The first level retry is a number of retries when an exception is raised, for example, because a transient failure, or like here, an argument exception is raised. Then it tries to invoke the code, the handler code, again a number of times. By default, it's 5 times. If after 5 times still an exception is raising from the business code, then the so-called second level retry comes into play. The second level retry mechanism puts, after the first level retries, the message back into another queue so that other messages can be hopefully successfully processed in the meantime. And then after a configurable amount of time, by default it's 5 seconds, the second level retry comes into play and executes again 5 times the code in question. I'm going to show you that. So I rebuilt, the sample is still the same, I rebuilt it, but I'm throwing an exception now in the enricher. So what I'm going to do is I'm going to run Elton's example on my machine. We see here on top the party enricher and the validator. The validator is successful, as you can see here on the bottom, but the party enricher 1 and the party enricher 2, they both raised a number of exceptions, and second level retry is now showing us that the message with some GUID has been moved to the error queue. So in Elton's sample, all that handling, like retrying and moving it to a secondary queue, second level retry, and then in the end, if everything failed, moving it back to the error queue we would have needed to code that ourselves. And NServiceBus does that for us. And it even does more. It tracks all the necessary information on that message moved to the error queue in order to know when we retry that message, as I'm going to show you later, to which destination queue the message needs to go and to be retried. I'm going to show you that soon. In addition to that, what we have shown, NServiceBus itself has by default auditing enabled. So what it does is each message successfully processed by an endpoint is also audited in an audit queue. This is quite handy if you want to see what your system is currently doing or has been doing in the past. So I'm closing now this sample again, and I want to fix that error. So I'm uncommenting that exception. I restart the whole sample. So the validator, the enricher, as you can see, it's now successful. But I've been lying because we only processed new messages at the moment. So how do we get the other messages which have been failing previously? And I think that's when I want to talk about that NServiceBus itself as a framework or library is actually part of a larger platform. So we can look, for example, into the so-called service pulse, where we can now see that a number of messages have been failing. We see here we have 20 failed messages in the queue. We can look into service pulse and see what was actually happening on that message. So we see that the exception invalid legal identifier, so we see the message of that exception. We can, if we want to look deeper, we can visualize the stack trace of what has been happening. This is all traced by NServiceBus for us. We can show the headers NServiceBus has been assigning. And of course you can also see that, for example, the enclosed message type, so the type of the serialized message is here, the identity name, we have conversation IDs, the originating machine endpoint, reply address for request reply. We have the exception type. All that information is available on the message. We can also visualize the message body so that we see the payload of that message. So here is, for example, the with trade ID 10. So if I want to retry all those messages, I can now, because I fixed the bug, I can hit the retry button. Before I do that, I try to reopen the enrichers so that you see it, because it's pretty fast. So let's close that one, and I hit the retry messages button. Okay. And everything was retried in a matter of seconds. It's doing that now. And as we can see, the screen is already updated and we see there are no more failed messages in the queue. What ServiceBus offers also part of the platform is that when we want to observe whether an endpoint or a host is currently running, it has the concept of so-called heartbeats. So if we close the endpoint, or potentially all the endpoints, after a matter of seconds, it will visualize that the endpoints are offline. So we could, for example, notify our operations team, or even the operations team could be notified in an automatic way. In order to get the heartbeats with ServiceBus, this is extremely simple. We only need to add a reference to a NuGet package, which is called, I'm zooming in, which is called service control plugin.nsp5.heartbeat. This is, by the way, also available for NServiceBus version 4 and NServiceBus version 3. So even for older versions, that's available. And as we can see, because the endpoint which are currently down haven't been sending heartbeat messages to the infrastructure, this is now visualized on the screen, and we can actually see which of the endpoints are active, and on the other hand, which of the endpoints are no longer active. So I'm going to close that. But if you want to get deeper insight in what has happening in our system, we can look into the so-called Service Insight application. As we can see, Service Insight visualizes each message flowing in the system. We can see we can click at each message. We can even do full text search. For example, we search for trade ID 10, search for those messages, and then we look into the body, and we see that it actually did a full text search even in the payload of the message. We also see a pretty nifty flow diagram or sequence diagram, how that message, where the message came from to which destination. So we see on one side, we see the producer, which also Mauro has been showing, and it has been received by the consumer application. We can expand, we can copy paste the conversation IDs, we can search that message, so we can really see how the message is flowing in our system. And what's even more interesting is in the case of an exception, I'm zooming in, we can actually see that the first attempt sending the message made that message processing failing, visualized here, and then we did a retry by using ServiceBus, and then the whole processing of that same message was successful. By the way, we could also do a retry here directly in this application. That doesn't really matter. And of course, we can also visualize all the headers on the message, the payload as I've shown before. Yeah, that's already it regarding first level retries, second level retries, auditing, and gaining an overview over the whole message-based architecture by using Service Pulse and Service Insight. I'm switching back now to the slides and giving a brief summary of what we have learned in that webinar. So in closing, before we come to the Q&A session, we can say that NServiceBus, as we have seen before, reduces the boilerplate code in your system. And also NServiceBus brings in a queuing infrastructure code, which is really battle tested, so we can build our infrastructure on top of the shoulder of giants. And as we have seen, NServiceBus provides this capability of first level retries, second level retries, and even auditing, and of course even more features which are not part of that short webinar. And I think in addition to that, NServiceBus is part of a richer, what we call the particular platform, so we can leverage the capabilities of tools like Service Pulse and Service Insight to get a real detailed analysis of our message-based architecture. So let's dive into the questions. Mauro, do you start?
More than a question, I have a comment right now that is a follow-up to what you just said related to the particular platform and what you showed about Service Insight and Service Pulse, is that the NServiceBus has no dependencies at all on the particular platform tools, but the opposite is true. So the particular platform tools are built on top of NServiceBus, so you are not required to run an endpoint. You are not required to run the particular platform, but you can leverage the power of the particular platform to better manage a distributed system and to better have an overview and a bird's eye view of what's going on into the system itself.
Mauro, there is a question from Kevin. He's asking, is Service Pulse and Service Insight available for Azure hosting using worker roles?
Yes, the answer is yes. Basically what Daniel didn't show because it was not part of this webinar is that both Service Insight and Service Pulse relies on a under the hood tool called the Service Control that is the endpoint that is listening to auditing and error queues and is collecting these failing and audited messages into its own database. Then Service Control exposes this information through a REST API to Service Pulse and Service Insight. Service Control can be configured to run on multiple transports as endpoints can do. So if your environment is designed to run on Azure, you can configure Service Control to use the Azure Service Bus or Azure Storage Queue Transport and grab messages from auditing and error queues on Azure, and then configure Service Insight and Service Pulse to connect to the endpoint, to the Service Control API endpoint.
So, okay, I think when we don't have any additional questions, we wrap the whole webinar up. So I'm showing quickly the last slide. The sample we've been showing you today can be found on github.com/Mauro Servienti/going async, or if you just go to github.com/Mauro Servienti, and Brit will also send out an email with that link to the sample, so that in case you forgot to note it down, that shouldn't be a problem. And so that's it for today. I'd say on behalf of Mauro Servienti, this is Daniel Marbach saying so long for now, and hopefully see you again in the next particular live webinar.